let's continue with where we left off from the last lesson. So I'm going to create the spline as requested. Is that add the spline to location A, which is on the shaft, to provide positive drive with gear 1. Spline data is 6 by 13 by 16, length of 20, radius 2. Okay, so this is a straight spline. So I'm going to here, go to the design, go to the parallel splines, which is straight. So over here, let's look at whether we have the size that we wanted. So we do not have it, so let's look at the medium series. So let's go to ISO 14. ISO 14 is the parallel splines. So the first reference I'm going to create on the shaft, followed by the flat face. So the orientation is okay. Radius is 2. And the length is 20. Okay, you notice go all the way to the end. Alright, okay, anything for the hub? Yes, maybe. Go to the hub here, click on hub. So the hub will be the gear itself. So flat face followed by circular edge. Okay, I want both to be done on the shaft and on the hub, and press OK. Alright, that's cool. So now I'm going to assemble them together. So assemble, constraint, axis to axis. Oops, something not right. Let me try again. Constraint, axis to the axis of the shaft. Okay, let me check. Apply, flush this with the front face of the wall. Okay, press OK, and then you check whether it spins together. Alright, it spins together. That's good. Okay, next thing is we want to put in the pin. So pin the pin, constraint, pin to the hole here. Alright, I'm going to apply, followed by the flat face. Okay, so now I'm going to create the gear. This is gear 1, and create gear 2. So gear 2, okay, where can I get information for gear 2? I need to open up the eccentric wheel roller PDF. Okay, so gear 1 and gear 2 will follow this roughly this dimension. So gear 2 is this detail here. However, the only thing unknown is the number of teeth. Okay, so how do we calculate number of teeth? So we first know that this is gear 1, module is 2, number of teeth 24. So my radius of gear 1 is equals to module times number of teeth divided by 2, which is 24. Okay, alright, so let's check it out. Okay, what's the center to center distance measure? Okay, center to center. 43.994, very close to 44. Okay, let's assume it's 44. So center distance is radius 1 plus radius 2. If this is 44 and radius 1 is 24, radius 2 will be 20. Okay, so PCD of my total PCD, okay, PCD of 2 is actually 40. Okay, so since I know that PCD is module the number of teeth, so is this 40, module is 2, so therefore T is 20. Alright, for this one, so here is 20. So when this 20, let's come back to here, let's go and create a gear, spur gear. Okay, and one internal, modules 2, number is 20, face width 14. Okay, 14 is from here, 14. Okay, and then helix is 5 degrees, make sure it's left. Let's hover and check for direction, it's left. And then we can say gear 2 no, and press OK. Okay, we're going to add this guy, open. Okay, we're going to add in the rest of the details. So it's going to extrude 3 mm. Okay, why 3? Because the face width is 14, so I need to add 3 on each side to form a total of 20 mm. Okay, punch a hole, 8 mm. Okay, I'm going to create a chamfer about 1 mm on both sides, so I can put in the gear on either direction. Okay, so I'm going to put this, give it a color. Okay, save. Okay, so I'm going to put in this gear to here. We're going to flush it with here, probably flush it with. Okay, so I want to make sure that this gear and this gear are always in mesh. Okay, on the flush, press OK. Alright, so what's next is to put in the okay, pin 1 to add circuit groove to prevent gear 2 from popping out. And what else? And then we need to put in all the items here. Okay, alright, so to prevent this pin from popping out, okay, I need to know what's the distance from here to here, which is about 4 mm. Okay, so I'm going to edit this pin, create a plane from here, push back to 4 mm. So the pin size, circuit size to create, so you can actually go to the module. Alright, go to the module, go to unit 4. Okay, you can go to open up this DIN 471. Alright, you notice that for 8 mm shaft, alright, this is going to be 7.6 groove size and width of 0.9. So how do you read this? It's by looking from here. G is the internal diameter, or rather the smaller diameter, not internal diameter but smaller diameter, and the groove width is T, which is 0.9. So come to here, S7, .6, project, extrude, .9. Okay, change direction. Okay, make sure you see the cut, and then you return. Okay, add in the circlip, external 471. Click on this smaller groove. Face will be biased against this wall here. Okay, so I have the circlip. Alright, so I have the circlip, or we call this the retaining ring for the pin. Okay, so this one I have it already. Alright, what else I have? I have the wheel roller, I have the shaft, I have the bearing, I have the retaining ring for the shaft, two of them. Okay, which is the item here. Circlip. Next thing I need to have, I need one more here for to put in. So just place, dead center, select the groove, select the wall, okay. Alright, next one. Bushing, yes. Housing top, yes. Base roller 1, yes. Gear 1, yes. Washer for the shaft, okay. Washer for the shaft. Okay, I need a washer for the shaft for here, and then also for a nut, so that it prevents the gear from popping out. Okay, so I'm going to add in the gear, add in the washer, plain washer, plain washer. Okay, what's the standard? 126. Okay, 126. Okay, just going to click on the shaft size, click on the wall that I want to press against, press OK, followed by the nut. Okay, so now I want the nut of size 14033 is the standard. 4033. So this one, put on the here, and then against the washer, put OK. So my nut has been created. Okay, what else? So nut is created, washer, nut, 4 washer for the pin. So this one actually is for the item here. Okay, before we put in the screw. Okay, alright, so I'm going to place, okay, washer. Okay, same thing, 126. I'm going to place the wall here, and then this thing, press OK. 1, 2, 3, 4. I need one more. Okay, for them, place is fastener. So this one have fastener of 4, 6912, 6912. Okay, I'm going to put in, okay, and I'm going to let it check for the size. You know this M6. Okay, make sure it flush to the top of the washer. Okay, the length you can adjust it to 25. Press OK. And check how many screws are being auto dropped into the SMD. So they are 1, 2, 3, 4. So once 4 is done, press escape. So I have my screw, I have my gear, and my pin. Okay, so all is counted for. This eccentric, this actually is not required. Okay, so let me just delete away this eccentric, this. Just press delete. Okay, so if you want, you can actually add in a constraint. Alright, so what's the gear ratio? So the gear ratio is 24 divided by 20, so it's about 1.2. Okay, so let me adjust this first. Okay, the gear tip are not so well defined because this is not the actual gear tip profile. So I'm going to press, go to constraint, go to motion. Okay, select gears, they are moving opposite direction. So what you do, just select this is my first one, this is my second one, and the gear ratio 1.2. Let's check whether it's correct or not. Press OK, and then my spin. Okay, notice that there's more error. The errors start to accumulate, right? So that means it's not correct. Okay, so what I need to do is I need to go to the gear, edit. Okay, change the selection. So 1 will be here, 2 will be here, and press OK. All right. So now you spin. You notice now it's better. Okay, so much better. So if you want, you can actually spin this. You can drag this. You notice this is how the eccentric roller assembly works. Right. So I want you to go ahead and complete the item here. So I need you to create the gears with the sectional front view with the gears on the left, a plan view and left view with the gears. Okay, so what do I mean? So basically I want you to create a view like this. All right, I want a sectional view with the gears on the left side. So this will be my plan, and then the right and the side view will be this view. All right. Okay, so I will end this video here.